of motion. This is also sometimes called as NLM. It means Newton's laws of motion. And this is me, Engineer Utkarsh Anand. For more info about me, you can please Google me. Now, let us move on to the contents of this lecture. Here, first of all, this is an introduction. So here we will try to understand what is first law, then second law, and then third law. So in this slide, let us talk about a football. So when you kick that football which is at rest, it means some external agency is needed and that football starts moving from rest. So basically you have applied some external force. You are that external agency. Similarly, when you consider a ball which is rolling down an inclined plane, then you apply some external agency, or this is what you have done. You have put a barricade here, and then this barricade actually stops the motion, right? So basically this is an external agency that is needed to stop the motion or retard the motion. Retard means reduce the speed. Similarly, you can see here, to throw a stone upward, you are making an upward push, but initially the stone is at rest. In all these examples, you are actually trying to change the speed of the object. Now, let us come to the next slide. Now, let us think about a situation when the stone is released from the top. Here once again, you have made the speed of this stone to change, but it's not you now, it's the gravitational pull of the earth. Similarly, there is a bar magnet, then it would attract iron nails even from a distance. In all these examples, there is some external force or external agencies that exert force even from a distance, like gravitational force acting on this stone even when it is away from the surface of the earth. Similarly, this bar magnet attracting the nail iron even from a distance. Dear students, the external agency may or may not be in contact with the body. So the external agent or external agency or external force, whatever we are talking about, that may or may not be applied by anything which is in direct contact. Now, let us move on to the next thing, which is the law of inertia. This is also called the first law of motion, or Newton's first law. So here let us try to understand that we are considering a body which is moving with a velocity v. So in this case you see a car. This is a old designed car. I would love this antique car. I don't know what the name is. Well, we need an external force to stop the slash, stop or retard the vehicle, right? So like friction or brake is applied to stop this vehicle or retard the vehicle. Retard means reduce the speed. Similarly, we need an external force to increase the speed. So well, if no external force is there, there is no change in its velocity. That's for obvious reason. Now, kids, let us talk about the law of inertia. What is this term inertia? Definitely this is the resistance to change. It means whenever there appears some change, then this inertia actually opposes it or resists the change. A body does not change its state of rest or uniform motion unless an external force compels it to change. So it is just like as if one fine winter morning you are sleeping, you are having a deep sleep, and all of a sudden your mama comes and forces you, "Hey Rohan, what are you doing? Wake up, it's already 9:30 a.m. So well, your mama has given you an external force, and because of that you have to wake up. So kids, this inertia is something that opposes any change, and if any body is in the state of rest or uniform motion, it will remain so unless any external force or mama comes and compels you, right? I hope you can correlate to this example. So here kids, we are talking about acceleration, we are talking about retardation, we are talking about neither acceleration nor retardation. So in this case, no external force, no change in velocity. But here there is an external force, which is definitely that here I would like to tell you that gravity is actually opposing the motion. Here gravity is actually supporting the motion. So in both the cases, the external force is gravity, right? So dear kids, I would like to tell you that whenever there is some external force, then there has to be certain change in the state of the body. But whenever there is no external force, then there is no change in the state of the body. It means it continues to be in the state of rest, or it continues to have a uniform motion. Dear kids, let us try to understand this with a beautiful example, and this was something which was thought by the great Galileo. I would like to write his name, the great Galileo, the scientist who laid down his life for scientific temperaments in the world where Earth was believed to be the center of the universe. But that story is a different part. We shall not continue with the atrocities committed by the people of the contemporary world with Galileo, sir. So well, I would like to focus on this example here. This is what you find is that the final height and initial height both are equal, and this is obviously a frictionless surface, so there is no friction. Similarly, if the slope, if it is made very long like this, then once again the ball reaches the same height, as you can see, right? And here we have tried to change the shape of this path. So now if we try to make the shape like this, so what would you think? Let us say it was like very big. I mean, it is something like this, and this distance travels up to infinity. So ball will tend to move up to infinity, trying to reach the same height here, right? But since it is a very infinite path, the ball keeps on going till infinite distance. So Galileo proved that on frictionless surface, the body travels with uniform velocity. That's all for now. Dear kids, this is Engineer Utkarsh Anand explaining you Newton's law of motion in a very lucid manner, in a very simple manner. I hope you liked it, and if you liked it, please share, please give your comments, and please subscribe to our channel for such interesting contents. Thank you so much. Love you all. Have a great day.